Hi, I'm Regan Smyth. I'm the Director of Spatial Analysis at NatureServe. NatureServe is the trusted source for biodiversity information in the Americas. If you'll bear with me for I promise it'll be 2 minutes of kind of boring traditional PowerPoint overview of what NatureServe is and the work we do. But then I'm going to switch over to a pretty engaging video produced by our partners at EPRI about how we use data science in that work. At its heart, NatureServe is a biodiversity informatics network. We lead this group of programs across the US, Canada, Latin America, including the natural heritage programs in the 50 states, to collect, analyze, and communicate information about biodiversity, imperiled species, and ecosystems. We provide information on, what's out there, where it is, how it's doing, and what actions will help. What can we do to sustain the biodiversity around us? Our foundational data includes documented occurrences collected by our network scientists over 50 years. This map shows, with these polygons here, areas of conservation significance for individual species. We analyze that data together with information characterizing the environment using predictive modeling to generate maps of not only where species have been documented, but where else they're likely to occur. The outcomes of these models can be transformational. By narrowing in on where conditions are favorable for a species, we can better direct conservation efforts and reduce conflict for industry. What you're looking at here are the model outcomes for a model we produced with the Florida Natural Heritage Inventory for the frosted flatwood salamander. On the left there, you see those areas that actually have conditions suitable for the species. If you can compare that to data previously available, things like the broad range maps proffered by the Fish and Wildlife Service, you really can see how this new information can make a difference. The area represented by those range maps is an order of magnitude greater than area we've narrowed down on with these models. In addition to developing data like that I just shared, NatureServe also develops tools so that information we produce can be quickly and efficiently used by the people who need it. Our state environmental review tools are just one great example of that. So switching gears a bit now, like I promised, I'm going to share that video produced by EPRI, where I speak a little bit more about how data science contributes to our work and how that's making an impact on the planet. NatureServe is a Western Hemisphere biodiversity informatics organization. We maintain data. We maintain data in the natural world, and particularly the species and ecosystems that are most at risk, that are most imperiled, that are least likely to persist into the future without the intelligent action of humans. We work pretty closely with the federal government, the Forest Service, or the Bureau of Land Management. We also provide data to industry. So if you're a forestry company or you're a pipeline company and you're trying to cite your activities and you want to do so in a responsible way and avoid areas where you have concentrations of imperiled species, the data of NatureServe is useful in those contexts too. All those people need biodiversity information, and we can support them all, as well as land trusts and conservation organizations and folks who want to know the key biodiversity areas to protect. That's another really important group and some of the users I'm most passionate about. ArcGIS is wrapped up in everything we do. We use GIS tools, EPRI tools in the field to collect data. We use them to aggregate data, and increasingly we're using ArcGIS Online and similar platforms to build web applications and get our data out there, both to serve the end users and to communicate within our own network. The Map of Biodiversity Importance has been an initiative to use the data we've collected on the most imperiled species, use machine learning, environmental predictor variables to predict where habitat for species is. With that, over the past year, we've built models for more than 2,000 species, and we're combining that information to produce, for the very first time, high-resolution maps of where you have concentrations of the species, the plants and animals that most need our help. The things that jumped out at us, those first looks at the map, it was like, wow, we're seeing what we knew. We're seeing the Appalachian Mountains light up for aquatic species, but we're also seeing some things we're not expecting. We're seeing the river in Minnesota that has a whole bunch of rare mussels and some really cool plants. And we're seeing parts of Utah that we knew had some neat endemic plants, but they're on fire on our map. And that was really neat. The future of GIS, the intelligence we are generating today can help us address problems that have plagued us for a very long time. I think there's often been a perception that species conservation and human development and human needs are at odds with each other. But now that we're producing better information on where the most important places for species are, we have opportunities we haven't in the past to make better decisions in ways that can support both the little critters that are kind of our natural heritage, as well as the needs of the people who share the planet.